Okay, so notice this is we're gonna write 9 rows of Pascal's triangle, and I just want you to see the patterns, okay? If that's too small, just let me know and I'll zoom it in. Um, okay, so notice this is, even though it's row 1, it's called row 0. So this is row 1, this is row 0, position 0, right? This is row 1, position 0, row 1, position 1, and we'll talk about that. Let's just see how we can get the next row. Row 2. So we get each element in Pascal's triangle by adding up the rows immediately above it. So the 0 here is understood, so 1 plus 0 is 1, 1 plus 1 is 2, 1 plus 0 is 1. And we can slowly build up Pascal's triangle by just finding the sum of the terms immediately above it. So here's row 3. 1 plus 0 is 1, 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 0 is 1. Okay, so now we have row 3. Even though it looks like row 4, we call it row n equals 3. We call this row 3, okay? So row 4, and we can do 1 plus 0 is 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1 plus 0 is 1. Row 5, 1 plus 0 is 1, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 5, 1. And let's just get it down to row number 9. 1, 6, 15, 20, 20. Uh-oh, that should have been a 15. Six, 1. Row 7, 1, 7, 21, 35, 35, 21, 7, 1. Row 8, 1, 8, 28, 1, 8, 28, 56, 70, 56, 28, 8, 1. And row 9 is going to be 1, 9, 36, 84, 126, 84, 36. Uh-oh, no, I made a mistake. Let's just get this right. I jumped the gun here. So this should be 126, 84, 36, 9, 1. Does everybody see how you can get each entry in Pascal's triangle? Can you guys remove your earphones, please? Hello? Yeah, I don't care. Get them on. Okay, so, all right. Now, how do I indicate this term number? So I'll explain that later. Well, I'll explain that in a few minutes. But let's just note and just look at Pascal's triangle. 1. Each term is the sum of the terms immediately above it. Right? Just like we got here. Number 2. The first and last term in each row is 1. The first and last term in each row is 1. 3. Each row, each term is represented by T subscript n comma r, where n is the row number, n is the row number, and r is the position number. Okay, so each term is represented by T subscript n comma r, where n is the row number and r is the position number. And note, the first row is 0, and the first position is 0. Is there anything you need me to reread? Is everybody okay with that? Okay, so let's take a look at this. Notice that 1 here is in row 0 and position 0. So T subscript 0 comma 0 equals 1. That's how you would indicate that term. So this is T subscript 1, row 1. This is position 0. No, yes. Equals 1. T subscript 1 comma 1 equals 1. Are you wondering why we're starting with 0? Weird, eh? It's different. Yes.
So the number to the furthest to the left, that's always the 0 value?
Yeah. This is position 0. This is, yes, this is position 0. Okay? So T2 comma 0 equals 1. T2 comma 1 equals 2. T2 comma 2 equals 1. Now, what I want to show you is you don't have to write out Pascal's triangle to get the terms. You can use it, you can find it using the combinatorial button on your calculator. Just look at your calculators. Do you have an NCR button? Look for an NCR. You're looking for a button that looks like this. Has everyone found it? Is there anybody who has not found it? Sometimes my NCR button is above my division line, but yours could be someplace else. Like mine is right there, but yours could be someplace else. Everybody has it? Okay. So, for example, now I'm going to say choose. I'm going to go N, choose, R. That's something we do in math data management. It's really how many ways can you choose R things when you have N things. You don't have to know that, but you're going to be wondering why I use choose per C, okay? So, let's say I want this row, but I don't want to write out Pascal's triangle. I don't want to write that out. So I can go like this. I can go 7 choose 0. See, this is the 7th row, and it's choose the 0th position. So if I were to go into my calculator and go 7 shift, I don't think you need to see my calculator, but 7 shift NCR 0 equals 1. See how I got the first term? Now, if I want the row 7 in this position, this is position 0, and I want position 1, 7 choose 1 equals, what do you get when you type 7, right? What's 7 choose 2? What did you get? 21. See how you can go to the you can get the entire row using these choose buttons. Okay? You don't have to write it out. So 7 choose 3 equals 35. 7 choose 4 equals 35. 7 choose 5 equals 21. 7 choose 1 equals 7. 7 choose 7 choose 7 equals 1. Okay? All right? So you don't have to write it out. You can get it using the combinatorial button on your calculator. So let's keep going. Number 4. T, this is a formula where any term in Pascal's triangle equals the sum of the terms immediately above it. So that's going to be n minus 1 r minus 1 plus t n minus 1 r. So, for example, how would you write t, the term in row 7 in the sixth in position 6? How could we write it using Pascal's formula here? Yes? Tn minus 1 and r minus 1. And then it's Tn minus 1 comma r.
Can you please read over that entire line again?
Sorry?
Can you read over that line again?
This one here?
Yeah.
T subscript n comma r equals T subscript n minus 1 comma r minus 1 plus T subscript n minus 1 comma r. So if I want terms subscript 7 comma 6, I would have to add what two terms? T what? T subscript. Well, if n is 7, right? If n is 7, n minus 1 is 6. And if r is 6, then r minus 1 is, right, plus t, well, if n is 7, n minus 1 is 6, and if r is 6, then r is 6. See how you can write it using Pascal's formula? Yeah, absolutely. However, we could use the combinatorial notation and we can say C 7 choose 6 is equal to 7 choose 5 plus 7 choose 6. So I could get, what is 7 choose 6? Well, T7 6 is row 7 in the 6th position. 0, 1, 2, 3, 4, 5, 6. So 7 choose 6 is 6, right? 7 choose 6, no, 7 choose 6 is 7. And do you notice that equals 7 choose 5s? Oh, I messed this up. Shouldn't that be 6, 5, 6, 6? My bad, I apologize. Let's fix this. So, do you notice 6, 5, 0, 1, 2, 3, 4, 5 is 6, right? And 6, 6 is 1. Do you see how that works? So 7 equals 6 plus 1. 7 equals 6 plus 1. Yes.
So, what is this for? What is Pascal's triangle?
Pascal's triangle is really interesting because of all its patterns. Okay? But what we're really going to, we really want to know Pascal's triangle for is for the binomial theorem. And we'll do that. If we don't do a bit today, we'll do it on Tuesday. Okay? All right. Now, point number 5. The sum of any row is 2 to the n. And I want to show you that. Watch this. 2 to the n. So watch it. n here is 0. 2 to the 0 is 1, right? Now, for this row, notice the sum is 2. 1 plus 1 is 2. So 2 to the exponent 1 is 2, right? 2 to the 2 to the exponent 1, 2 to the row number equals 2. Notice the sum is 2. 2 to the exponent, the row number is 2 equals 4. Notice the sum of all the terms is 4, right? This is 2 to the 3 equals 8, right? Notice this adds up to 8. 1 plus 3 plus 3 plus 1 is 8. So tell me, what's the sum of row 7? Sum of row 7? It's what? 2 to the exponent 7? 1, 2, 8. Right? That's okay. Okay, good? I'm going to go over this on the next few pages, okay? All right. Pascal's triangle and the binomial theorem. It's named after Blaise Pascal because he noticed there's many properties about Pascal's triangle that are quite interesting. So notice, row number 0, the sum of the terms is 1, right? If we were to just go through and add up all these rows, the sum of the terms in row 1 is 2. The sum of the terms in row 2 is 4. The sum of the terms in row 3 is 8. And that's 16. So if we were to come up the formula, which I told you already, it's 2 to the n. That's the formula for the sum of the terms in any row of Pascal's triangle. So what's the sum of the terms in row 15? 32,768. So as I said before, we count the rows of Pascal's triangle starting at row 0. Similarly, we count the terms in each row at position 0. We use the terminology T subscript NR to denote the term in row n position R. So tell me, what's the value of T subscript 31? 3? What is it in T subscript 55? T subscript 72. Are you using your choose button? You can do it that way too. What do you get? And then 7 choose 3 is? Okay, tell me. What is the term directly below T72 and T73 in TNR form? T8, right? Whenever you're adding, pick the largest position number. So what's the equation that relates these three terms? T8 comma 3 equals what? No, but we want an equation equals what plus what? Right? T subscript 7.3 plus T subscript 7.2. Can you write an equation for this guy? If you have these two terms, what would the equation be? Equals? Yeah. Can I explain anything better? Yeah. You need lead? Yeah.
So Linda, how did you get 7 T83?
Here? Well, any term in Pascal's triangle equals the sum of the terms above it. So you're in the previous row, 8 minus 1 is 7, and then you add T7 3 plus T7 2. Because the formula is this, Tn comma r equals Tn minus 1 comma r plus Tn minus 1 r minus 1. Okay, so 8, n minus 1 is 8 minus 1 is 7, right? N minus 1 is 7. R is 3, so that one's 3, but R minus 1 is 3 minus 1 is 2. Yes?
Why is it that we like skip a space every time? Like to get triangles.
I just did it to give us more room. There's no special reason. We didn't have to. Do you mean, why is there a row between rows?
Yeah.
No special reason.
Organized.
Other than, spacing. Can I answer any questions on this?
What is that?
So,
It's not this to the right.
sorry, I can't hear you.
It's Tn comma r. No, on the right. Yeah. Equals to Tn minus 1 r plus
Tn minus 1, r minus 1.
thank you.
We're going to write it, we're going to summarize it on the next page. So as I said before, any term in Pascal's triangle can be written using combinatorics, right? Each term in Pascal's triangle is equal to the sum of the two consecutive terms in the row immediately above, given by the formula Tnr equals Tn minus 1 r minus 1 plus Tn minus 1 r. Using combinatorial notation, it's n minus 1 choose r minus 1 plus n minus 1 choose r. This is known as Pascal's triangle. So tell me, rewrite this using Pascal's formula. Oh, sorry, it's known as Pascal's formula, my bad. Rewrite this using Pascal. How can we write 12 choose A using the formula? Sorry? Yeah. 11 choose plus, yeah. And this would be equal to? Yeah. Good? What I want to show you is Fibonacci sequence. Basically, the Fibonacci sequence is an interesting pattern where any term in this series of numbers, like Tn, is equal to Tn minus 1 plus Tn minus 2. So let me show you what that means. I'll illustrate. Any term is the sum of the immediately preceding two terms. So let's just write Pascal's triangle here. This is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. So this is, Fibonacci sequence shows up in many places. So the sum of this is 1. Notice we're just adding this. There's only one term here, we're adding it. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 plus 1 is 5, right? 1 plus 3 plus 1 is 5. That's 5, 8, right? 1 plus 4 plus 3 is 8. 1 plus, that's 12 plus 1 is 13. So the Fibonacci sequences, notice that the 2 is equal to the sum of the terms preceding it, or 3 equals the sum of the terms preceding it, 5 equals the sum of the terms preceding it, etc., etc. It's an interesting, we're going to talk about recursive formulas. This is a recursive formula. Can I answer any questions? A recursive formula is a formula where you need prior terms to get the next term. And we'll do more on that next week. Can you guys handle more? Be ready to handle more on Tuesday, okay? I don't, the binomial theorem, which we're doing next, is so critical that I don't want to rush it. You're going to forget it by then, so we'll leave it. So I'm going to do a lesson and a half on Monday, on Tuesday, and a lesson and a half on Monday, okay? Maybe I'll do 2 lessons on Tuesday. I think we can handle 2 lessons on Tuesday. We're done for now.